Good morning, good Saturday morning. Welcome to Coffee and Chat with Goshen Publishers. I am Sean P. Richmond. I am the editor-in-chief, the founder of Goshen, and we've started these coffee and chat sessions to be held at least once a month. And we're holding them to showcase our authors and their new books, some of them brand new, some of them have been out for a while now. But the reason I've started hosting these sessions again, we tried it some time ago, but the reason I'm doing this is because we have authors who are subject matter experts in various industries. For example, we have many faith-based authors who write Bible-based books. We have other industry experts such as Dr. Nathan Rogers, who's written about his published research based on informal learning. We have Dr. Kimberly Hayes, who's written about conflict resolution. And so one way to help our authors promote their books, but also to reach broader audience with their expertise is with this coffee and chat. So hopefully you'll bookmark our calendar at goshenpublishers.com. You'll stay tuned for future authors and future events so that we can support our authors as they get their content out there. Today's feature author is Brice Richard. He is the author of Conquering Our Basics. If you are familiar with Microsoft Excel, you'll be excited to see what you can do with R that Excel cannot. If you're familiar with Python or other programming languages, I think you're going to be fascinated to learn what you can do with Conquering R Basics. Brice's book is an easy to read page turner. It's colorful, it's got illustrations, it includes QR codes to free tutorial videos. He put a lot of thought into the design of this book, and today he's selected one topic. And before I hand the mic over to Brice, just to let you know, the way that we decided on today's topic was Brice was featured last month at the Howard University Middle School on STEM Day. And he gave a wonderful presentation, a talk about R. The 8th grade students were interested in learning more of some of the art features. And so Brice has agreed to come by and show us a couple of more of the cool features of R. I'm going to hand the mic over to Brice now. Again, I'm Sean Richmond. I'm going to moderate the chat. If you have questions as he's presenting, feel free to drop them into the chat. And I'm happy to jump in. Brice doesn't mind with your questions as he proceeds. Thank you so much again for being here. Enjoy your coffee, sit back, enjoy learning about R, and by all means, let Brice know if you have questions as he presents.
Thank you, Sean. Thank you. So sound check. Can you hear me?
Absolutely.
Okay, good, good. So my name is Brice Richard, and yes, I did in fact write the book Conquering Our Basics. Today, I want to explore kind of the artistic side of art. Now, I want to make a distinction before I begin between generative art and generative AI because they're so closely related in terms of the topic. Generative art is basically a separate distinction from generative R. I'm sorry, generative AI. So generative AI with regard to art is where you type in what's called a prompt in a particular user interface, and then through the use of what's called a large language model, the image is created from nothing more than an expression of the words. Generative art, conversely, is where you have a particular algorithm. It's not a large language model, it's an algorithm that generates the art itself. So it's completely based on mathematics. And so the goal I wanted to showcase today is the objective of this talk is to offer ideas that will achieve two goals in developing an instructive course for an 8th grade class of students. So, what are those two goals? The idea is to share generative art through the use of art to evoke a desire in students to learn more by developing an interest and a curiosity about technology. The sooner that you can get students interested in technology, the more compelling their existential arcs and paths in lives will be. Technology is ubiquitous, as we know. And then the second one is to use technology to stimulate student creativity. I can't think of a better way to stimulate creativity today in the world in which we live than to foster a curiosity and creativity as it relates to technology. But to be able to do that, we have to be able to establish kind of a modality or a mechanism by which to do that. So, for those of you that have purchased the book, thank you very much. This should be familiar to you. If you have not purchased the book or you're not familiar with R, just a very, I'm gonna break this down into the smallest component elements because if we're talking about students and eighth graders particularly, this really needs to be simplified in terms of their ability to be able to use it. So the way that I've thought about this, forget about this window here and this window and this window. Just kind of focus on this empty window here in the lower left-hand corner of the screen. So the way this works, the way I'm envisioning this working, is that there is a library in R called Artsy. So as you're teaching this, what you want to do is have this probably pre-installed, and you just hit the enter key, and it loads that package. And what that does, and that package is shown in this, it'll be a little check mark there that says generative art with ggplot2. Once that you have that installed and loaded, then uh, I'll take you to, these are what are called functions. Now, what I've highlighted in red are the artistic pieces that you can use through what are called functions. So don't let this overwhelm you. All these are models of how to do this. The reason some of these are highlighted in red and not others is because I've selected, there's 22 of these, any number of which, if you're teaching students on how to use these, I wouldn't use maybe more than 3 or 4, just to kind of simplify it. But the distinction here is that some of these that are not highlighted, I would not recommend use because it takes a long time. It can potentially, depending on your processor and your computer, it can take a long time to generate them. Having said that, let me show you what these images look like from nothing more than, before I actually show you the actual code to do it. So I'll show you a few of these. So this is an example of what these are all created through mathematics. These are just some of these. Some of these are more abstract than others, but again, this is the artistic look and feel. I'm gonna focus on mazes because I'm gonna showcase another incarnation of how we can use this to really foster creativity and innovation in children. Children are very innovative if you give them a modality within which to operate. So this is swirls. Again, each one of these are created with mathematics. So I've chosen a couple of these, and the way this works is for the canvas of the maze, you just type in, this is called the function canvas maze, and then a color. That's it. It's one perimeter, and then we hit the enter key, and over here in this window, it actually produces that maze. Now, there's a lot going on under the cover here, but again, we're targeting an eighth grade class, so I want to really simplify what we're doing. If you click the zoom, you can see that this is a maze. And now we can change the perimeters. I think where this will stimulate child creativity, student creativity, is that, first of all, this should be interesting to students initially, but you can change the perimeter. So instead of orange, we could do green. And what's really nice about this is that the color green is also stipulated here. And then we can create a green maze. So children can start playing around with this and kind of host their favorite color, but there's a lot of other things you can do as well. For example, we can play with what are called perimeters. So instead of just creating a green maze, which is kind of interesting, but there's more that we can do. If you put a comma, we can also change the color of the walls. So right now the walls are black. We could say make them red. And now we can have a green maze with red walls. So what I'm trying to do is stimulate the student to kind of play with these perimeters. Now, they're going to be learning what a function is just by doing this without ever having really told them what a function is, because they're learning through doing. And hopefully this will stimulate kind of an interest in more of a desire to learn more. We can change the background. So if we add another perimeter, we can change the background color to say yellow. And what that will do is change the background color to yellow. Now you can also export these into images, and you know the children can literally, at least with this particular visualization, have a game. They can try to use a pencil. If you could print it out, you can literally play the game through the maze. Another one that we can do is we can actually change the entire shape of the maze. If we use polar, this is a binary perimeter. Binary means it's either true or false. So we can say true, because right now it's set to default false. And what that does is change the entire look and feel of the art piece. So now it looks completely different. It's polar, what's called a circular maze. And there are a ton of these perimeters that you can design. If I were to work with you for an instructional manual, I'd make recommendations on which one of these functions would be most useful for this. Let me do one more. I'm going to do what's called canvas flame. Now, the colors that we're using is Dodger blue and green with a background of white and variations. Variations means, if we go to this canvas flame here, the variations is an argument to be used with specific variation of the flame. And there are 48 different possibilities. So as children become made aware of this, and these are just numbers. You put in a number that can give you the kind of the variation type. I like this because of the variability of it. It really is designed to foster the creativity of a child. They may see this and go, oh, what's polar? What's handkerchief? What's heart? And then they can put the respective number in the variation. So we're going to use 3, which is swirl. So it's going to give me a look and feel of a swirl with these colors and the background of white. And this is what this looks like. Now, what's interesting about this, because this uses a random number generator, which means that you're using a different configuration of numeric values plotted against a Cartesian X and Y grid, this is going to look different every time that you run this. So if a different student were to run the same exact code, it's going to give you a completely different view of this. So you see these are radically different. They're similar, but they're different. And then we can change the color. I mean, really the options and the variability of this is almost infinite on what you can do. Very artistic side of R. And we could change the color. So instead of Dodger blue and green, we could do yellow and let's just say purple. And instead of the variation of 3, we can say, what do waves look like? 15. So we'll put 15 in here. This is very easy to do because these are just perimeters. If you know what the perimeters are, this is what this looks like with kind of this is interpretation of the wave. But it's very interesting how the idea again is to really kind of foster the creativity and let the child kind of associate that this is mathematics doing this. Nobody is drawing this. This doesn't come from the mind of someone. This is mathematically based. Somebody created an algorithm with these different parameters that would create a different view of this. And there are 22 of these that you can use: smoke, strokes, swirls, termite, watercolors. So depending on how much flexibility that you want to create, if you were using this as an instructional guide, would determine to what extent you want to utilize these. I wouldn't use more than 3 or 4 initially, depending on, you don't want to overwhelm the child's choices. I would recommend doing something very basic like this. And then those students who have more of an interest on their own, they'll probably ask questions, and then you can expand on this. But let me take this a step further, because up to this point we've been talking about 2 dimensions. So I want to talk about changing this into 3 dimensions. And there are wonderful implications for why you want to be able to do this. Just to go back to the first incarnation of this, which was the wave, I'm sorry, the maze. So this is a two-dimensional model of a mathematical algorithm that creates this, about which we spoke earlier. But there's something more radical that we can do with this, and I think this next incarnation of this will kind of showcase this. So, as we move into what's called the metaverse, which is the world outside of the internet that's on another level, it's basically a multi-dimensional place where you universes, and it's like almost like a game environment. So what this next exercise is designed to do is to foster kind of an introduction into what that is from the R's perspective. In other words, how would you introduce the metaverse through R using something like this? And the way that you would do that is you can go online and you can convert this file. Right now, this file is a PNG, or you can store it as a JPEG. But if you convert it into a GLB, and there's a free conversion online that allows you to do that. What you get now, imagine this is the two-dimensional version of this. Now imagine that you have a three-dimensional version of this. So what this is this allows me to literally, this is almost this would be what you would see in the metaverse. This is a three-dimensional version of this. We can spin this around. The child can literally like move inside of this. And then these options here allow you to change the colors of it. Now, there is a version of this online. So if you're using a Mac, I'm using a Microsoft 3D viewer. If you're using a Mac, you would use an online version of this, and we can talk about where that's at. But I like showcasing this because I'm a Microsoft guy. So this is the Microsoft version of this. Now, if we left click under stats and shading, this gives me a completely different view. By the way, there are 109,000 triangles that create this. So if you wanted to kind of focus on that in your teaching, you can kind of show the complexity of how this maze was created from a 2D to a three-dimensional space. Now, these vertices allow us to look at this a little differently. By the way, this is a maze. A child might interpret this as a circuit board. Wouldn't that be interesting? And could be used as a circuit board. So you're using a maze to maybe transition into circuitry or electrical engineering. And this poses some very interesting implications for what a child might interpret, again designed to foster creativity. One more example of how this can be radically change the orientation from a maze to something completely different once you start looking at it through the lens of of of, three dimensions, is another context in which you can use imagery aside from or in addition to using R, is using generative AI. So generative AI would be like, and I would recommend this site here if you wanted. This is generative AI. So what is this? This is typing in prompts using a large language model to create your images. And there are a ton of these sites. I like this one if you're talking about students because there's no programming. And in addition to, if you're going to use this professionally, something like this, you would need to use a very elongated, specifically defined prompt. Here, though, you have the art styles. So the student would just be able to pick a style, and the picture representing the name is kind of indicative of the summary of what the style would look like. And then you can create the picture. Now, I'll come back to this, but this is how I created. I digress. That's how I created this. So what are we looking at here? This is a tire rotor. This is just a rotor that you would see on a car. It really has no other significance than it's kind of an interesting re- high resolution graphic of a PNG. But what makes this more compelling in the eyes of a child would be if I converted this into a three-dimensional GLB file, what would that look like? Because it's one thing to be able to kind of look at, your mind is going to process this differently in two dimensions than it would three dimensions. So what I'm getting ready to show you is the exact same pictorial graphic version of this, except in three dimensions. The reason I'm focusing on this, I want you to kind of get a sense of what this looks like in 2D. Now, mind you, this is a tire rotor. And then what we're going to do is show this in 3D. This becomes a three-dimensional world. This is the same tire rotor, three-dimensionalized. and the student can use this to kind of navigate through this. What I'm seeing is a potential game could be made out of this, like a maze. You could go through this. Um, it could be, it has engineering implications, it has visualizations, architectural implications to be able to navigate through the rotor in 3 dimensions in a way that you cannot do in the 2 dimensional version of this. Here are the vertices. This gives us a little bit of a different view. You're looking at the same thing, a different view. This has healthcare implications to be able, instead of or in addition to biopsying, for example, say a mole, and you want to determine whether it's uh, it's malignant or benign. You could take a picture of it, convert it into 3D, and look at the benign nature, or look at the nature of the wart, or the whatever the issue, whatever the pictorial is in 3 dimensions. And this allows us, if you statistically model this in 3 dimensions, you can do some very interesting things. So in the future, instead of or in addition to biopsies, you're going to be able to look at whatever the malignancy or the disease is, and you'll be able to statistically determine attributes of that, characteristics like the growth rate. You could compare these. For example, if we had two rotors, we could compare the rotors from maybe a damaged rotor or something hyper perimeterized and small that might indicate, for example, this these pieces here coming up are indicative of a manufacturing malfunction. So you might be able to look at this through a visual lens, or you would have AI look at it and automate whether there is a problem with it or not. Are there any questions so far about what I've discussed?
Uh, Brice, so far, I think we're doing great. I'm hearing from Dr. Lofton that the Dean of Students, I can't tell. Amber, if you can text me your question or drop it in the chat, if the Dean of Students has a question for Brice, that'll be fantastic. Otherwise, I think I don't see any other questions, at least not in my private chat. So I'd say we just proceed, Brice. This is fascinating.
It's
Yeah,
it's not necessarily a question, but it's more so I'll send an email, but Brice he really likes the program.
yeah. So the idea is, again, to simplify this. This kind of concludes this demo on this, because I wanted to simplify it. I could go into more detail if there's an interest on looking at some of these other functions, but this is the idea. Basically, just to kind of recap. So the idea is to encourage students to exercise their creativity and their curiosity by showcasing how to create two-dimensional clip art pieces or visualizations, both using R and something like this tool here. Let me actually just talk about this for a second, generative AI. And then secondly, is to then be able to transition that visualization, showcasing the value proposition to students from 2 dimensions to 3 dimensions, and then allowing the children to have interactive kind of an interactive relationship with the visual. And I believe this will foster extraordinary opportunities from the child's perspective. They're going to be asking questions. Oh, you might ask them. Here's what I wanted to say. I'll come back to this in a second. With regard to, say, these visualizations, whoops, you might want to ask them, once they have access to these, to ask them to connect an emotion. How are you feeling today? If you were, what are the exercises I would proffer would be to ask the students, once they have a fundamental understanding of how to create these art pieces, is to say, want you to create an art piece that best represents your emotion today. Are you feeling happy? Are you feeling sad? Are you feeling irritated? Which art piece best describes that? And let them go through with all these different parameterizations and create their own personalized art piece. Then have them write a little essay, a couple of paragraphs about why and what, to what extent or to what degree the art connects to their emotionality. And the reason that I like that, and the reason I'm offering that as an opportunity to as a learning opportunity, is because it connects you to art in a visceral way. Art by definition is visceral in many ways. So even something as abstract as what art can produce has still a visceral component to it. And children, I think, would benefit from that greatly by connecting their emotionality to pictures. And it would also justify them wanting to do it and give them a reason to want to learn R from the perspective of the mathematics. So you're kind of very cleverly connecting, art to emotion to mathematics, which is really, really important. Going back to going back to this particular kind of visualization, so the idea here is to really simplify the creation of using generative art with visualization with prompts. So the way this works is, and I've got a prompt history here. We can take a prompt, and you can take, it's basically two steps: a prompt and a style. Trying to think of something that makes sense here. Generate a metro rail car. And there's a million different styles here, and the children would just have just a blast selecting the style, because the style, even though you have the same prompt, will create a completely different visualization. So if we do comic from the perspective from that style and generate a metro rail car, it creates 4 images, and then you can refine the image once it creates the image. So to create 4 kind of different interpretations of a metro rail car, and you use this button here to kind of explode it, and you've got, now this is from a cartoon perspective. So if we take it from, let's say, a realistic perspective, same prompt, and then click create. Again, very simple, and you're controlling for the different styles. So there's nothing added to this. Makes it a little more realistic. So a little bit of a nuance there. And then if the student liked a particular version, you could click make variations. So I'm selecting this lower left-hand corner. I want variations of this. And then it puts that in the upper left-hand corner and gives you different variations. So again, tying this back to emotion, the child would then be able to maybe refine their emotion based on, or refine their pictorial representation of that based on a particular variation of the picture. And this just goes on and on. So, but this is the idea, is to be able to really minimize the amount of effort involved and get the maximum value from this. And there's just so much here to experience. I don't know that this is necessarily overwhelming, because it's kind of pictorial and you can just experiment with all these different versions. This, by the way, this company comes out of Canada, and they're constantly updating and upgrading this. And so it's a marginal fee. I got a lifetime membership. It's like $200. But it's like, I don't know, $15 or $16 a month to be able to use this. You could get a few licenses, and away you go. With regard to R, it's open source, so this is free to download and use. So creating the visualizations from this perspective, from an economic perspective, is really worth considering. Considering it's free, you just need to understand kind of how to use it. So that concludes my demo. If there's any questions, I wanted to really simplify this so that I could represent this from the view of an eighth grader's eyes.
Thank you, Brice. We do have one other question from a middle school math teacher. We're looking at your book cover. Do you have that image? It might be
Sure.
on your welcome slide. They're wondering if you could explain the image that's at the top underneath the word conquering and the code at the bottom.
Yes. So actually, good question. Actually, on the website, I wrote something that really kind of, on my site where my book link is. There's an audio that really goes into detail on what all of this means. So the two characters they're male and female, and they represent individuals at the ready, both male and female at the ready, using a technology. They're prepared to fight the world, and to be able to solve problems. Essentially, the code at the bottom represents what's on the back cover, and that represents that if you make major changes in your life, I use mathematics create a plot, and that code represents that if you make radical changes in your life, and the change that's being recommended is learning this technology, that you forever change the baseline of what you had existed before. So the average of what your decisions were in the past, when you make a radical change, you raise the baseline. Now, the squiggly lines, the red and the black squiggly lines up there in the upper right-hand corner, those are unique to finance, which is you've heard of being in the black or being in the red. So this is the liability and the asset that comes along with learning. In the beginning, learning is a liability because you don't know anything. It's difficult. It's often painful emotionally to learn something new. There's frustration when you learn something and then you have a difficulty applying it. But as you learn and build your knowledge, you turn to an asset, which in finance is considered being in the black. So that squiggly line kind of represents kind of the chaotic nature of learning process where you're kind of it's a transition from the negative to the positive.
Fantastic, fantastic. Congratulations on a wonderful demo, Brice. And I'm saying wonderful because there are two schools that have just expressed an interest in bringing Conquering Our Basics into their curriculum. That's, I think, looks like Friendship Heights Middle School and Howard University Middle School. So we are excited to be a part of what's happening with STEM in particular, but to bring something as powerful as R into the school systems, I think is just it's fantastic. It's exciting as your publisher, of course, but I'm just excited to see where education is going. I'm looking forward, Brice, to perhaps a coffee and chat where we also bring in Dr. Rogers, Nathan Rogers, to talk about R and AI and informal learning. So that one's on our radar. And I'm just excited to see where it goes. We have a question in the chat from Dr. Kimberly Hayes. Hey, Dr. Kimberly. Her question is, what's next for you, Brice?
Mm,
I think I
what's next
maybe
for me?
kind of sort of answered it a little bit, huh?
Well, I mean, what I'm working on now is I'm doing research. I'm working with DHS, and they're trying to understand how a biological agent, if it were released in the public, how it would move through space and time. And so this is allowing me to be able to use machine learning. I really want to focus. What's next for me is to really be able to convert all of the by the way, R has 20,000 packages. So this is really a splinter. It's really a microcosm of a very small part of what R can do. It's represented in every science and technology domain on the planet, as well as the social sciences. There are things you can do, for example, in the social sciences, psychology, economics. There's just packages that really focus on. I don't want to present this as only R is basically artistically based. This is one component part of it. It's represented in a variety of different ways, and so I can work with any of the educational folks out there who are interested in really any topic. You give me any topic about which you want to discuss in the context, and there I can find something for you within R that can focus on that. What's next for me is really converting because R is changing so fast. To give you I have a tool that monitors this in real time, by the way. So any new innovation that comes out in the world through the lens of R, I'm notified within 24 hours. So I'm on literally the cutting edge of what is on a global basis, what is currently available in this technology from people around the world and academicians and scientists and statisticians and mathematicians who manage their own packages throughout their universities and their research studies. And I've talked to a lot of them, and I'm actually collaborating with a pharmacokinetic PhD up in Massachusetts, and where he put a package up called Quick Code that we are adding functionality to kind of expand the capabilities here. And I've shared some ideas, and we've developed and collaborated. But what's next for me is to be able to take these innovative capabilities and convert them into reproducible process models, so that I can write. I'm writing a ton of white papers on this. I've written over 218 articles on the tool of R, and so a lot of that is process model based. So long answer to a short question. I apologize, but that's what's next for me is to really convert everything into reproducible process models to be able to teach this to others.
Thank you so much, Brice. Thank you. Thank you for that question. Dr. Hayes, thank you for the questions from the two middle schools, Thank you, Amber, for your support. Thank you all for logging on with your coffee to chat with Brice on Saturday morning. Coffee and Chat is something that we'll be doing every second Saturday. Wow, the comment says Brice is definitely prolific in his field. I agree with that. He encourages us, doesn't he? He inspires us to dive deeper and go broader. Coffee and Chat is something that Goshen will be hosting the second Saturday of every month. We invite you to invite others to log on, get to know our authors, get to explore their fields, learn about topics such as R. These are the basics, but of course, Brice clearly is prepared to go deeper with the discussion and tutorials. Learn about the soft skills, conflict resolution, learn about informal learning. For those of our authors who are, again, faith-based, we have the deep dive Bible studies coming. So please mark your calendars for the second Saturday in every month to grab your coffee and log on. Jay Thornton will be taking us into some futuristic and sci-fi discussions about his characters, Jackson and Tacion. And I'm excited about the variety of our the variety of our genres and where we're going. And we appreciate your support in the land of Goshen and supporting each of our authors and each of their products. This will conclude our coffee and chat this morning. Thank you again, Brice. You can't see me giving you a virtual applause, but this was fantastic. Thank you all very much. And then our concluding comment, Brice, in the chat, the comment is, this has definitely given me some awesome new design ideas for extra characters. That's interesting from an author who's writing futuristic sci-fi, that he can use potentially R and AI to generate characters. So great job again, Brice. Thank you all for your support. Hope you have a beautiful, wonderful rest of your weekend. I'll see you on the second Saturday of next month.
Thank you. Thank you all.